operations.
Okay.
So.
That's all we need to do for this, right?
Yep, you're good.
Okay, cool.
Yeah, you're good.
All right, we're good.
Perfect. Okay. So it's like, what is a vector?
Do you want to scoot over here?
Yes.
Sorry, that was closer to the board. It's the both of us. Sorry. Now you can face. No, that's exactly what you wanted.
I don't know about me. I'm bald. You might see a reflection, dude. So sorry if you get some light in your eye. Okay. So what a vector is, from my understanding, it's pretty much just like a point on the line that has like an origin point and then like a direction angle.
Okay.
Well, is that how you understand it?
So I'm gonna turn right up better. So I mean, yeah, I'd say you're exactly right. It's got a starting point and it's got a direction that it's going, basically.
Right, and then it has like a point on the line, like, so like you'll get a point like this vector is -5, 2, -2. So we'll see. We'd look at it, say go over -5 spots, go down 2.
Yeah.
That's where the vector should be.
Uh-huh.
That makes sense? You get that?
Yeah. Doesn't it have to do with like, so how I understood it was like it had like the direction it's going, so direction as well as the magnitude, right?
Yeah.
Okay.
Yeah. And magnitude, like to be honest, I don't know exactly what the magnitude is, like what's
I think that's
represented.
like how long it is.
Okay. Because I know how to get the magnitude, but I was like, I don't know. I was like, I don't know. Like, okay, sure. I just know how to get it. Okay. So what is the other vector operations? They're pretty easy. Okay. How to get it? How to find it? Find the magnitude. If you're giving A and B, you just do like the absolute value of the vector, like a V in absolute value bars equals A squared plus B squared, which is under a square root.
Yep, exactly. Pythagorean theorem, right?
Yep.
Also, one thing that my brother taught me about vectors that you guys probably already know because you're both really smart is like you got your vector going this way and then you got your vector going this way. And he said that you always take it goes head to tail. So you put the tail onto the head, just like the head vector because it's the top one. So basically it's like this would be like A plus B.
Yeah.
So then you have the tail and then this is your vector here. But then if it was B, A minus B, it would be, here's your vector normally, you take it, and then you put it right here, and then this would be your vector. So you always take the tail and then just stick it on the head, and then the direction depends on if it's negative or positive.
Yeah.
Does that make sense?
Yep. That makes tons of sense.
Sorry, could you see that?
Yeah. When you were explaining, I've seen that done before, so it was just
Okay, cool. Yeah, like I said, you guys are super smart. I'm just not quite on your level. So
No.
when I learned that last night, I was like, oh, that's cool.
I'm not.
whatever.
So vector operation, addition, subtraction, scalar multiplication,
It's pretty crappy.
dot product,
It's not bad.
angle between two vectors.
So addition, subtraction is the easiest.
Yeah.
Just take whatever it tells you to, and you minus the stupid things or plus them. Like that one's pretty easy. Like I was like when I was looking at the problems before, I was like, "Freak, how the heck am I gonna like do?" And then I was like, "Oh, it's not bad.
Yeah.
That's not bad at all." So, and then scalar multiplication. I don't know if I'm just thinking of the right thing, but like I think that is the scalar just basic. Because I think it's pretty easy, right? It's just times the two things together. So I'm thinking scalar multiplication. Now I get it, what it's asking.
Okay.
You take it, so like you get two vectors and you have to multiply them together. So like this one's a perfect example. So U times V. So let's say I'll just do it on the most easier. Just so I can, this is pretty much for me so I can remember. So let's say U is a vector, U equals 4, -3, V, I should have done it right here, but sorry, Jordan.
No, it's all good.
Let's just switch it. What's this one say? Okay, let's do that. -4 x 4, and we want u times v. So I always just wrote it out. That's a1, that's a2, that's b1, and that's b2. And so u times v equals a1. Let's see if I did it right. Yeah, okay. A1, B1 plus A2, B2. So pretty much just take 4 times -4, we get -16. A2, oh yeah, that's right. A2 is -3 times 4, we get -12. We plus them together and you get a -20. Cool. Yep. Okay. That's scalar multiplication. Feel pretty good about that. Pretty easy. Makes sense?
Yeah.
Yeah. I just remember that, like, for any letters, I was with the A1 or whatever. If there's 3, then good luck. All right. Okay. Scalar dot for dot product. I don't know dot product. I know I did get the answers, but I don't. I can't explain it very well.
Do you know how to explain dot product, Jordan?
No, I have no idea what that is.
Okay.
You'll do the homework and you'll see it.
Cool.
Product. Is that like the? No, never mind.
Do we want to look it up or do we want to just do it on our own?
It's not that hard.
Okay. That's
It's
okay.
really not.
I'll do the homework today, so no worries.
Okay. Angle between two vectors. I mean, that's pretty easy. Don't they usually give us it's like 150 degrees and then you just
It's like,
stretch from 180, basically,
it's-
depending.
so like, okay, so this is where the problem sucks because you have to find the direction angle. And that's pretty much what it's asking, right?
Yeah.
So this is where you kind of need, like, the unit circle helps you on this one because let's say they give us, like, let's say we get the angle, the direction angle is 50, let's see. I have one over here. Okay, the direction angle is like, okay, let's say they just give us a vector, like 1, -3. We find the magnitude, and then we have to find the direction angle. And depending on where we find, like this, because we'll go find 2 angles, you find like the original angle, and then you have to take whatever quadrant it's in and minus it or crap like that.
Okay.
So let's do 1.6.
Okay.
I can just do this problem.
Okay.
But I can just explain it. So you get this -71.6. Well, if we looked at -71.6 on a unit circle, what quadrant would that be in?
Would be in the fourth.
4th quadrant, right?
Mm-hmm.
So what number is like 4th quadrant like kind of tied to,
270 to 360.
right? So we would take 360 because it's -71 and minus 71.6 from it, and you get the direction angle.
Okay.
So that's the angle between the 2 vectors, which is 2. Like on this one, it's 288.4.
Gotcha.
But like, so that's just for 1. So I don't know, like for 2, so we're looking for like the resultant or whatever.
Mm-hmm.
And I think that's what you said, where you get like the u plus v, you get that, and then you have to find the angle of it.
Yeah. Okay.
And so I'm not great on this, so if you know it, go for it.
I wouldn't say I'm great on it either, but I do think I kind of know it a little bit.
Good, like show us, take it away,
Um,
because I think this will be a good help.
I mean, is that that's just like B plus? It's just like basically like you're talking about like when they give us like the coordinate like -3, 2.
Yeah,
I mean,
and I can find a direction angle of that pretty easy. But
What's the one specifically? Can you give me a problem?
that's what I'm looking for, one that has that says find the angle between the 2. And the only one that he gives us one like that is, I think it's it's like, let's do between V and V. So one is -3, 2,
Okay.
and then the other vector is 1, 4.
1, 4.
Yep, and find the angle between those two.
Okay. So I'm not 100% sure on this one.
So I have the angle that he gives, but like, we'll see what you get. Because like I did some problems the other day, and I don't think they're right.
So this is 2. This is 3, and then 1, 4. This is 1, and this is 4. So right now we've got. So we need to find this angle. It's the
like the middle angle right there.
So we need to find the angle between this and this, basically, right?
Yeah. Yeah. It says find the angle between those two.
Okay. So then we've got it's not a 36-90 triangle, but we've got a 90-degree angle here. So we can use SOHCAHTOA to figure it out. So we could say, let's see, this would be adjacent over opposites. That'd be tangent, right? So we say the tangent of theta equals
that makes sense.
Opposite over adjacent 4 over 1. So we take the inverse tangent of both sides. Tangent negative 1 equals, tangent 4 over 1 equals theta. Does that make sense?
Yep.
Cool. So then we get theta equals, we'll just say 40 degrees, just for the sake of the argument. Then we do the same thing for this one. We have this angle. We're going to say opposite over adjacent. Tangent equals -3. Inverse tangent. Equals, we'll just say 40 degrees also.
Okay.
So then we have 180 minus this plus that is
80, so it'd be 100.
So it'd be 100 degrees.
Okay.
Does that make sense?
Yep.
That's what I think. Makes sense in my mind. I don't know if this is the best way to do it or what, but yeah, SOHCAHTOA. Does that make sense, Jordan?
Kind of.
Cool. Yeah, it's
Does it go over in the homework, like in the My Math Lab?
So I've looked for a problem that did this, and I couldn't find one. He gave us a preparation one, so I like looked at the answer to see how you could find it, and I was like, I'm not sure. So
okay.
I know, like, so if you go to the lesson 1 prep and do the problems, the extension problems, it's number 2.
Okay.
And it's like the last part of that problem.
All right. Cool.
But he doesn't show you how to get it. He just gives you the answer. So you kind of figure out how to do it from there. But if I do this, I think I could do it.
Okay. Cool.
Because you have the values already.
Mm-hmm.
The bottom, right, adjacent for this one on the left would be saying that's this one. That is -3, and that's 2.
Yeah.
And so you just put them in, and you do the tangent with it.
Exactly. Yeah.
So it's not that bad. I think we can do it.
Yeah, for sure. So pretty good. So going on to the problems. Oh wait, are we done with these up here?
We could go discuss what a polar coordinate is and how to plot a polar coordinate. It's pretty easy.
Okay.
Only one I don't know is between the cardinal and polar, but because I was like studying some of this last night and then studying some of it, I didn't finish all that. I didn't finish all my homework either,
yeah.
So I'm like, okay, but I know what polar points aren't bad.
Okay.
So, and plotting them is pretty simple, straightforward.
Gotcha.
So where's my notes? All right. Okay. So like these are polar points, like 2, 5 pi 6.
Mm-hmm.
Okay. So plotting it like, so I'll just plot all these things. You probably know more than I do.
I don't know about that.
So we draw to plot polar points. We draw like a little right, and I'll just do this one because there's only what's the highest? 3 is the highest. So I'll just do 3. So then what we do is we have to draw circles. First level, second level, That was a little off, but whatever.
It's all good.
Okay, so we do that. And so like here's let's say this point is 2, 5, 5, 6. So this is where we have to like understand the unit circle. So it's 2, so we have to go 2, right? So then what angle is 5 pi 6? And so you look on we look on our, what's it called thing, and it's like, oh, it's 150 degrees, which is this way. So we go 2, 1, 2, 150 degrees, let's say it's right there. That's the point. Cool. Pretty simple, straightforward. So if we had a different point, then you would just like, because like this is positive, right? So we're like, oh, it has to go over to the positive side. But it doesn't really matter. It's just 2 in the direction of the angle. And you get the answer.
Gotcha. Okay. Interesting.
I know. That took me a little bit because I was like looking at how the plot points, and I'm like, why the heck would we do that?
Okay.
Right.
Cool.
Pretty easy. Okay. I'm learning how to convert them right now. So I can do a couple, but like I can like tell you what I'm doing.
I feel ya. Converting between their 2 points. Ensure that each team member was able to develop the formulas converting found in question 6 of the preparation.
Okay, this problem is okay. So do you know what the dumb formulas are?
I don't.
Okay. I'll show you now.
Okay, thank you.
Okay, so the formulas that specifically, and I didn't fit like this is so the problems that we're gonna do, like the extension problems or whatever, like we go over in this part of it. I did one of them, but we'll kind of see. So here we go.
Okay.
So there's 2 different things. So I'll just label it like he did A and B, and there's formulas for each of them. So the first formula is given R and theta, right?
Okay.
Or is that theta?
Yeah.
Yeah, guess what I thought. So when you're given those, you're gonna get this, which is like, so I was like, what the freak is this? Like, how the freak, like, what are you talking about? It's just like -1, 2, right?
Okay.
Okay, so you get, I mean, it's the opposite. That's okay, I'll just go through the problem. So you get x equals r cosine theta, right? Because r is, what does r stand for again? I don't know. What's it?
Do you remember what R stands for, Jordan?
I'll look up my problems, but
No, I
and
don't.
then the other one for it is y equals r sine.
Okay.
Okay, so for this one down here, when we're given, this is the one I was thinking of.
Gotcha.
So when we're given x and y, this one's a little more complicated. There's r2 equals x squared plus y squared. Then there's r equals, it's like this is the one we already know. And then the next one is there. So those are the formulas. But the problem is you have to like convert between formulas and crap like that. I'm like, oh. So like he gives you like example, but I was like, I don't get this one. But like for this one, the A equals R. So maybe you can explain it better. I'm just gonna do this. R equals 2 cosine of this, right? And so then what he has you do is go like through these problems, like to convert it
Okay.
to the next thing. And so I'm like, I don't know exactly. So the next part he says is like R to R minus 2 cosine. Yeah. And then with theta in parentheses right there. And then the next part goes to, so I think he's having us do is like converting this with these ones, like interchanging them. And so that's why I was confused, because I'm like, I don't get it. Like if you give me these two, I can find the solutions for X and solutions for Y.
Yeah.
Those are just the 2 points on the line you're looking for.
Uh-huh.
I mean, the coordinate vectors, right?
Yeah.
And then given X and Y, doing this is a little more tricky, but right. And so the next part goes R squared equals 2 cosine theta. And then the last part is X squared plus Y squared equals 2X. Yeah. So I was like, I don't know how we went from this to those. But that's what he's like wants us to do in problem 6. He's given us like an equation, and we have to convert between these equations.
Okay.
All right. So what he wants us to do now is there's 3 equations, and I did one of them. So it's like number 1 will be y equals 3x minus 2. And the next one is x squared plus y squared equals 9. And then the last one is r equals 3 over 1 minus cosine theta. And we have to convert them to like the answer, like to what the answer is.
Okay.
So I got this one, which was because so we just use like this problem, right?
Okay.
Or whatever, like use that thing, and I got r equals 3. And so because I'll use that right there.
Okay.
Right, because if r squared equals x squared plus y squared, we need whatever 3 squares that, 3 squared is 9.
Okay.
That's easy. Like that one was super easy.
Gotcha.
And so like but these ones, I'm not 100% sure.
Which one were you able to do, Tanner?
This one right here. So x squared plus y squared equals 9. I don't know
Okay.
if you can see, the light might be that guy. So the answer is r equals plus or minus 3, because it's kind of just like this one's simple, x squared plus y squared. So we look at this formula, we're like, okay, that's the formula right there. R squared has to equal these two. So 9 equals that. So we just need to find what was like, because this 9 equals r squared. So whatever squared equals 9 is the answer, and 3 squared is 9. So, but it doesn't, like, you don't know if it's positive 3 because that gives you 9, or negative 3 gives you 9.
Yeah.
So that one was super easy. I was like, okay, I got that. But this one and this one, I was looking at, I'm like, I don't know.
Okay.
So I'm guessing, like if you look at the formulas, see like this one.
Can we use those guys up there too?
Yeah, like because this one is this because it's that, because we're giving x and y.
Uh-huh.
Right? So this one we're giving x and y. So we're gonna have to use one of these formulas.
So this one we definitely know is
This one is this, right? And so we're given R and we're given this. So we have to do X equals R of cosine. All that fun stuff. But I see that's where I'm at, because when we look at it, we convert them, and I'm like, well, I don't see, we're not really given R, because R equals this. So maybe we have to do the problem to get it, right? And we're not given this. The answers are on here. Like, we can look at the answers, but like, I don't know how we get them.
Let's look at that answer situation. Oh gosh. Wait, would it be on this other one?
I'm not sure.
Would be, was it the preparation?
Yeah, it says it's number 6.
Is this it?
No, go to the one. I think these are problems we're supposed to do today, actually. I just skipped you guys. I'm sorry.
You're good.
Yep, right there.
So it's the very last one, number 5.
Yeah. This one right here. Yep. So we have it's down at the bottom there. Okay. So this one is saying number 1, saying we get -2 over sine theta minus cosine theta. I don't.
-2 equals sine theta over cosine theta.
I mean, R equals -2 over. Sorry. Let's do that.
Wait, sorry. Sine minus
Yeah.
sine theta.
Yeah, that's the answer. I don't know how the heck we get that.
Okay.
Let's see if I'm getting this right. Because we're getting, I think we're using this problem for it. I think so.
Maybe this one?
Well, yeah.
Because, so let's say y equals that. So we could say r of sine theta equals, just saying that
Yeah.
this is that, equals 3x minus 2. And then we could subtract the sine of theta from both sides, or we could divide both sides by sine of theta, so we get sine of theta,
No, leave R.
and we leave r.
But then how the heck do we get rid of the negatives? I mean, to get rid of 3x. And then for me, like, I'm like, because if we're doing, like, let's say 3, like, x, because x is cosine, right? Y is
Yeah.
sine. And so we don't have y, so this would make sense,
Yeah.
right? But we have cosine. And so that's what I was like, and it's cosine minus sine. But so that's why I was just like getting confused.
Yeah, I hear you. Yeah, I'm not really sure how we go from this or anything to this guy.
Yeah.
Mind bender.
And so like then we got this guy, r equals 3 over 1 minus cosine theta, and the answer is x equals y squared over 6. And minus 3 over 2. That's the answer. You have any ideas, Jordan?
No, dude, I have no idea how they're converting those.
I'm hoping today they show us like on the homework or whatever,
Yeah.
so I can like. I was looking at this morning, and I got the second one, no problem.
Yeah.
But like the first 2, I'm like, I have no. That was so. I was like, I had no idea how the heck you got those answers.
Uh-huh. So we could plug this.
So I was thinking like the r squared 2 cosine theta.
Mhm.
Wouldn't that be
like r squared 2 cosine, you mean r equals 2 cosine theta? Or-
Yeah, like
Okay.
that one. When do we use those two and then switch for y? We would switch cosine and put sine.
You're saying like this value and for the
Yep.
y?
Yeah,
for
and then
this-
solve for it, but then I still don't see how the heck we're getting rid of 3x.
Um, the answer to this one is r equals this.
Yep. So that's why I'm like, because
Kinda,
I get I think we r cosine, right? The r cosine, r sine is the x and y value. And then we have to factor out the r.
Hmm.
But I don't see how we get rid of the 3x. That's where I'm just like, what?
I mean, if you guys want to move on, we'll ask one of the math tutors real quick and see if they know.
That's fine if you want to.
Okay.
And me and Jordan will just keep trudging along.
Sweet. So we skip down to number like the end, right?
Here. Hold on. He has a Mac and I cannot use this to save my life. Do you have a Mac or do you have a,
I have a Mac, yeah.
see,
What do
you
you try?
guys? Okay, that's fine right there. How do you scroll down?
2 fingers.
You just put one on and then scroll with the other?
Yeah, we'll just do 2. Like, can you just either move it up or move it down, like this? It's like,
Oh, okay, I see it now. Okay, got it. Okay, so ensure that each team member was able to develop the formulas for converting found in question 6. So we have the formulas, we just don't know how to do it.
yeah, I have no idea how you do those, how you convert them.
Okay. And so then the next one is, so given 2 vectors, how would you find the resultant vector? Draw vectors and resultant vector. This one's pretty easy.
So that's what he was talking about with like the head and tail thing, right?
Kind of. So this is what it is. Like, so I looked up the answer and I remember seeing it's like this. So like we're given, let's just say we're given a vector here that goes like that.
Uh-huh.
And we're given a vector here that goes like that.
Uh-huh.
The resultant vector is this guy right here. Let's say let's name him U and name him V. Sorry, they look too similar. That's vector V, that's vector U. And we want this. So this is the resultant, right?
Uh-huh.
And so this one would be the resultant equals U plus V. So if you plus these two together, you'll get the resultant.
Okay, that makes sense.
Yeah.
See, yeah, I got that
Pretty
one.
easy. When you do the homework tonight, it'll make a lot more sense. Okay, and so then the next one, problem 2, I looked at this, I drew the picture, and I just do not So
Oh, the Joseph Smith one.
yeah, so like I drew a picture, right? So drawing a picture for this one, we got this, like, so just going off what he tells us. So we got one guy, like one horse is pulling this way with 200 pounds of force. Right, we got this. Then the next one.
So yeah, one's going off one way at 200 pounds.
Okay, so we got that one. And then the other one's going off at the other direction with 300 pounds, right?
Yeah.
Okay, and so then it's a parallelogram and it has a 360. So we draw these like dotted lines.
Oh, that's what is that what the dot product is or no?
I think it might be.
Okay.
So imagine the two horses have an angle of 65 degrees between them. So I'm guessing this is 65 degrees right here.
Wait, where does it give you 65?
It says, like right towards, it says, imagine that two horses have an angle of 65 degrees between them. One horse is pulling at 200 pounds. The other is pulling at 300 pounds. The force would be the magnitude of a vector. What is the magnitude and the resultant force?
Oh, so 65.
And then what is the angle between them? So, okay, so this one, if I know how to do magnitude correctly,
So the
magnitude is just
be like the resultant vector, right?
yeah. So we got V equals A. Let's say this guy's A, and that's B. Right. So equals A. So I'm guessing it would be like this, and you would get 200 squared plus 300 squared. I'm just guessing. Okay, so then if we do that math, we end up getting, it's going to be ridiculous. That's 40,000, and then 300 is 90,000, so would be 130,000 pounds a square, right? So we take the square root of that. Hey, what is it? Do you have the answers to these?
Yeah, hang on real quick. Let me look.
What does he say the magnitude or resultant force is?
So it says that it's 425, but I don't know how you get that.
Well, see, that's I did it, and I didn't get 425.
Yeah. But it has like, so he's labeling the magnitude, so which is basically like the resultant vector, right? So
Yeah, it's this guy
parallelogram.
right here, right?
Yeah, so he has it labeled R.
Okay, R.
But in the answer, it says like R and like the absolute value. That's what the straight lines are, right?
Yeah, so this would be R.
The absolute value of R equals 425.1. But I don't know how you get 425 out of that.
I don't either.
Because I initially, like just looking at it, I thought you just added the 200 and 300. But it's not that.
See, so if we took, yeah, because we took 200 squared plus 300 squared, we get 130,000. What's it was 425.1, you said?
Yeah.
Yeah, that doesn't give us, that gives like 180,000. 366.51. So yeah, like I don't know how the heck we got that. Because to find the angle, we have to have the magnitude.
How would you find that? So yeah, that doesn't make any sense.
Yeah, I'm not seeing how you get that.
It's 425.
Because first off, we're not given R and we're not given that. We're given X and Y, aren't we?
Yeah, but we can find so if you do 180 minus 65, that gives you 115, which is the angle of where the dotted line starts.
Okay.
That's 115.
That would give us 10 of that then, wouldn't it? Sorry, let me.
I can't see.
So if you get 180 minus 65 for the dots, 180 minus 65, we get 115. So would it be tan, 115, 300 over 200? Does that give us 425? Let's see. That equals, that's not it, no. Because then if we redid it, yeah, no.
There's not a right triangle anywhere, is there?
I don't think so. Doesn't look like it.
Freak. Yeah, I don't know how to do that one either. Maybe and David knows.
Yeah, I'm not seeing how to get that at all. Okay, let's just skip to that's and then number three. Number three is
It's just like part of what we were doing earlier, right?
it's exactly what we were doing earlier.
R and theta, then x equals r cosine theta, y equals r sine theta.
So the original equation is a circle with a radius of 1 and a center at 1.
So how do you identify the center and radius of the circle? Do you know?
Yeah, I don't know. Like these questions when I was looking at them this morning, like going off what I've done my homework on, because I've done all the homework on vectors, and so I haven't done all, and I've done half of it on the polar coordinates, and I haven't done anything like this in there yet. So
Freak.
and how I learned is I just let the math, like my homework, step me through the problems, and I learn how to do it, and then I just can do them.
Yeah, my math lab helps me a lot too if I've done
Yeah,
it.
it's a good one. I really liked my math lab. It was just like the same thing I took last year. It was like my Math Excel.
Oh yeah.
Yep.
Uh-huh. Yeah, I don't know how to do those equation ones. Let me look real quick. Yeah, I don't know, man.
Well, I don't think it's that big of a deal. We could learn because we still have one more meeting on Thursday, when the test opens, and we can do that, like kind of study, get ready, and we can come back on Thursday and go over this too. Because on Thursday we're just supposed to go over, like, we're just supposed to review for the exam anyway.
Okay, maybe we could do that. Maybe when David gets back, he'll know.
Yeah, when he gets back, we'll talk about it. What he wants to do, and
Okay.
he says he's waiting for his tutor still that could help him.
Okay, maybe he'll know how to do this one. Because once you find the magnitude, the rest is easy.
Yeah, and so like you find the magnitude, then you can find the angle. Then you can find the
So then it wants you to find what's
angle
between
between them.
those two other angles, right?
Yeah.
Yeah. Cool. Yeah, wait till he gets back and then maybe see what he says and maybe just text me or something.
Yeah.
And then yeah, on Thursday we can walk through this stuff we didn't know from today and then everything else. I'm kind of freaking out about the test. I don't like I'm glad it's not timed because then I can
It's at home too, which is nice.
What's that?
It's not like we have to go to a testing center or have a.
Oh yeah, that's where I struggle, man.
I know. So it's like the test. Like I'm not super scared for the test. The only thing I'm scared about is this crap.
The vectors and stuff.
Yeah, because like I could do vectors with the polar coordinates and like converting equations and crap. I'm like, no.
Yeah. Yeah, I have no idea how to do that.
But yeah, we have one test, and then we have test 2 in like 2 weeks, and then our final.
Oh, we have a final?
Yeah, it's just all multiple choice.
Oh, that's not bad.
No.
I thought it was just one more test. Yeah, we only
Yeah, we have 2 exams, and then we have a final exam. If you look on the last week, it's like week 7 or whatever.
Uh-huh.
it's like it shows the final exam and then the other exam. Like the exam 2 has like a written portion and a multiple choice portion, and the final just has a multiple choice.
Oh, that's not bad.
No.
Yeah, we only have like 3 weeks left, huh? Thank goodness.
It's like almost done. So I mean, after we take this test, we only have like 3 weeks left, and so we'll just
Up like all of my time.
yeah. Like I was telling David, I was like, I usually work on this class Monday through Thursday, and then I work on my other 2 classes Friday and Saturday.
Yeah, that's how I am. But all right, man. I'm gonna go. I gotta go pick up my wife from class.
Go for it, man. We'll see you Thursday, same time.
Yeah, Thursday. Let me know what David says when he gets back.
Sounds good.
All right, thanks, man.
I'll see you.
How's it going in here?
So Jordan had to leave,
Okay.
but we went through the other problems. Like so, we don't know how to do this problem either.
Okay.
Because I thought I did, but I obviously don't. So this problem right here.
Okay.
So because it says like find the
So
magnitude.
sorry, I've got a tutor in there waiting for me.
Go for it.
I just wanted to because we figured out one of them. We figured out this guy,
Okay.
but I think I might have written the answer for that one wrong. Answer. The first one is
Yeah.
so it's -2.
Over sine theta minus cosine theta. So do you want me to stop the broadcast?
Sure. You want to?
Because I was like, it's just me in here.